을 맡고 있는 연세대학교 이상호입니다. 미래기술 추천강연위원회에서는 70주년 기념사업위원회에서 1년여 전부터 준비하며 엄선하여 선정한 몇 가지 주제를 가지고 5분의 국내외 석학 및 전문가를 초청하여 우리 사회가 직면하고 있는 주제별 현안 문제와 이를 해결할 수 있는 정책 방향과 신기술, 그리고 새로운 미래의 기술 발전 방향을 살펴보고 토론할 수 있는 미래기술 초청 강연 프로그램을 준비하였습니다. 지금 식사를 하시는 오찬 시간에는 미국 국립과학재단 NSF의 공학 분야 토목, 기계, 산업혁신분과 프로그램 디렉터를 맡고 있는 조이 푸시키 박사님의 특별 강연을 시청하시겠습니다. Advancing Research Frontiers into the Future라는 제목으로 약 25분 정도 강연 동영상을 시청하시겠습니다.
Greetings. My name is Joy Pauschke, and I am a program director in the Directorate for Engineering at the United States National Science Foundation, which is abbreviated as NSF. NSF is located in Alexandria, Virginia, just across the Potomac River from Washington, D.C. I would like to extend my congratulations to the Korean Society of Civil Engineers on their 70th anniversary. I would also like to thank Professor Song-Ho Lee, President of the Korean Society of Civil Engineers, for this very kind invitation to speak at this anniversary meeting. In my presentation, I will highlight how NSF is advancing research frontiers into the future through its support for a wide range of research and education programs in science and engineering. My presentation will cover 3 areas: an overview of the National Science Foundation, an overview of the NSF-supported natural hazards engineering research infrastructure, and examples of NSF-supported research and innovations. NSF began in 1950 as an independent agency under the executive branch of the federal government. The National Science Foundation Act of 1950 sets forth NSF's mission to be to promote the progress of science, to advance the national health, prosperity, and welfare, to secure the national defense, and for other purposes. For this mission, NSF invests in basic research and education across the full spectrum of science, technology, engineering, and mathematics, known as STEM disciplines, invests in basic research to enable transformative breakthroughs and lead to new ways in thinking about scientific, economic, and socio-technical challenges that face the U.S. and the world, supports research and workforce development programs that help drive future economic growth and enhance the nation's security and global competitiveness, and supports advanced instrumentation and facilities, Arctic and Antarctic research and operations, cooperative research between universities and industry, and U.S. participation in international scientific efforts. I would now like to show you a video that provides an overview of NSF.
This is about discovery,
pushing the edge of the known.
changing the way we live.
Did you ever use a CD, cell phone, barcode, that thing they call the internet?
Maybe a touchscreen, LED lights, a web browser, GPS.
Ever get an MRI, do a Google search, check a weather forecast?
Every one of those things was improved on or made possible by fundamental research supported by the National Science Foundation.
And there's also 3D printing, laser eye surgery, safe for cars.
New biomedical tools, improved disaster preparedness.
Even disease-resistant bees.
Today, NSF supports people and places to develop tomorrow's scientists and engineers.
And create new knowledge in fields from A to Z.
We're the only federal agency that supports fundamental research in all disciplines of science and engineering. And we fund and manage the United States Antarctic program.
Every year, we receive about 50,000 research proposals. Each is evaluated by a diverse mix of university faculty and others who help NSF assess the significance and quality of the proposed research.
NSF's rigorous merit review process is considered the gold standard the world over for evaluating proposals in a competitive environment.
We fund about 12,000 new awards annually.
And every year, 93% of the Foundation's budget goes back out to support more than 360,000 researchers, teachers, postdoctoral fellows, trainees, and students at 2,000 institutions.
Well over 200 NSF-supported scientists later received the Nobel Prize for their groundbreaking discoveries.
Since its inception in 1950, NSF investments have helped build the backbone of the U.S. scientific enterprise
And transform universities and colleges into centers of scientific innovation, creativity, and discovery.
The result? New knowledge, technologies, and products that continue to address societal challenges,
Fuel the economy and strengthen national security.
shape the U.S. as a world leader in science and technology,
And enhance the well-being of people across the U.S. and around the globe.
What really causes economic growth is it's always innovation. So how do we get more of it? We invest in basic research. That's as simple as that.
As you can see from this video, NSF supports a wide range of topics in science and engineering. In order to support broad areas of science and engineering, this slide shows the organizational structure of NSF. NSF is led by a director, and under the director, there are 7 directorates shown on this slide in green that support science and engineering research and education.
현재
These
동시
7
통역이
directorates
진행되고
are
있습니다.
biological
여러분들
sciences,
리시버에
computer and information
채널 1을
science and
이용하시면
engineering,
한국어
engineering,
번역을 들으실 수가
geosciences,
있습니다.
mathematical and physical sciences, social, behavioral, and economic sciences, and education and human resources. Within each of these directorates, there is a wide range of programs that receive proposals and support awards for research and education activities. NSF also has cross-cutting programs that support interdisciplinary research and education. Funding for NSF is provided through appropriations made by the U.S. Congress, the legislative branch of the federal government. In the President's fiscal year 2022 budget request to Congress, NSF highlighted its 3 pillars to provide support for research, workforce development, and capacity building activities at the frontiers of science and engineering. The U.S. federal fiscal year starts on October 1. These 3 pillars are: 1, advancing the frontiers of research into the future. This includes supporting breakthrough technologies and supporting research in new industries such as advanced manufacturing, advanced wireless, artificial intelligence, biotechnology, quantum information science, clean energy technology, and microelectronics and semiconductors, and supporting climate science and sustainability research. 2, ensuring accessibility and inclusiveness, which provides support to advance equity in science and engineering, investments for education research across all levels of learning, and broadening participation in science and engineering through targeted programs and building capacity at minority-serving institutions. And 3, securing a global leadership in science and technology through transparency, reciprocity, and research integrity, as well as forming partnerships with other agencies, private industry, and other countries to leverage resources for advancing research frontiers. This slide provides an overview of what we call NSF by the numbers. NSF's enacted fiscal year 2021 budget was $8.5 billion. Annually, NSF provides support to 2,000 colleges, universities, and other institutions, evaluates over 40,000 proposals, supports 12,000 competitive awards, and supports over 3,000 people. NSF provides 24% of the total federal support for academic basic research in all science and engineering fields, with up to 87% in computer science and 43% in engineering. Since 2017, NSF has been building a foundation for pioneering research, new research infrastructure, and broadening participation activities through what it calls the 10 big ideas. This slide lists the 10 big ideas. These include the future of workforce at the human technology frontier, growing convergence research, harnessing the data revolution, mid-scale research infrastructure, navigating the new Arctic, NSF 2026, NSF includes quantum leap, understanding the rules of life, and windows on the universe. In 2022, NSF will continue to invest in the big ideas. I would just like to highlight 3 of these 10 big ideas listed on the slide. The future of work at the human technology frontier, this big idea focuses on interdisciplinary science and engineering research to understand and build a human technology relationship, design new technologies to augment human performance, and to foster lifelong and pervasive learning with technology. The Harnessing the Data Revolution big idea supports fundamental research in data, science, and engineering, the development of a national scale approach to research data infrastructure, and the development of a 21st century data-capable workforce. In navigating the new Arctic, as Arctic temperatures are warming faster than nearly anywhere else on Earth, this big idea aims to establish an observing network of mobile and fixed platforms and tools across the Arctic to support research to understand the Arctic's rapid biological, physical, chemical, and social changes. This slide shows 4 awards that were made under the NSF Big Idea for Future of Work at the Human Technology Frontier that may be of interest to the civil engineering community. This includes the future of remanufacturing, human-robot collaboration for disassembly of end-of-use products, the future of teleoperation in construction workplaces, wearable safety and health-assistive robot collaboration for skilled construction workers, and understanding the relationships between humans and technology to improve the quality of work life in smart buildings. NSF also supports the construction and operations of a wide range of science and engineering multi-user facilities, as shown on this slide, that enable basic research, such as research vessels, telescopes, ocean observatories, seismological facilities, shake tables, and wind tunnels. The United States is vulnerable to an array of natural hazards that put structures, essential utility infrastructure, people, communities, and regions at risk. These natural hazards include earthquake and windstorms, such as hurricanes, tornadoes, thunderstorms, and derechos, tsunamis, and storm surge. One of the multi-user facilities supported that would be of interest to the civil engineering research community is the Natural Hazards Engineering Research Infrastructure, or NHERI, or simply NERI, which is funded by the NSF Directorate for Engineering, Division of Civil, Mechanical, and Manufacturing Innovation. And I am the program director for NERI. NERI is similar in concept to the Korean Construction Engineering Development Collaboratory, or COSET. NERI is a network of university-based experimental facilities and computational resources that provides researchers with the state-of-the-art tools to investigate the impacts of earthquake, windstorms, storm surge, and tsunamis on constructed infrastructure and natural environments. The 12 awards that comprise NERI are shown on this slide. These facilities include a network coordination office, cyber infrastructure, a computational modeling and simulation center, and 8 experimental facilities, including a large outdoor shake table, which is currently being upgraded from 1 degree of freedom to 6 degrees of freedom, wind tunnels, geotechnical centrifuges, a large wave, flume and directional wave basin, hybrid simulation capabilities, mobile and field testing equipment, and resources for conducting post-disaster field investigations very shortly after a natural hazard event. NSF's various research programs support investigators to use the NERI facilities in the conduct of their research. NERI is coordinated through the Network Coordination Office led by Purdue University, and the Cyber Infrastructure component led by the University of Texas at Austin integrates all of NERI through the web portal known as DesignSafe. Design Safe is the one-stop shop for all information about NARI. I would now like to show you a video that describes NARI and its facilities.
Hurricanes, tornadoes, earthquakes, tsunamis, among the natural hazards that can devastate and disrupt entire communities. NEARI, the National Science Foundation's Natural Hazards Engineering Research Infrastructure, is designed to help make our civil infrastructure safer and our communities ultimately more resilient to natural hazards. The NEARI network includes 11 research facilities at universities across the United States. Home to some of the nation's leading engineers and scientists in natural hazard mitigation, each facility provides unparalleled capabilities in wind generation, seismic testing, wave experimentation, and computational modeling and simulation. As shared use facilities, the laboratories are open to researchers from a variety of disciplines and institutions. Each NEARI facility offers rich training and mentoring opportunities for students and early career professionals from institutions across the U.S., as well as U.S.-based research teams with international collaborators. It's all part of NSF's long-standing commitment to expand the pool of next-generation researchers. For decades, NSF has made substantial investments in research to explore and test groundbreaking concepts to protect homes, businesses, and civil infrastructure from the peril of earthquakes, wind, and water. NSF's investment in NEARI continues this legacy of innovative thinking, ensuring that state-of-the-art cyber infrastructure, simulation technologies, and laboratories are available to the natural hazards research community. And NSF strongly encourages integration and interdisciplinary collaboration, bringing teams of engineers and social scientists together to tackle the most complex problems associated with hazards research. In a world ever more turbulent, NEARI envisions resilient civil infrastructure built to withstand extreme events. The NEARI network and the associated natural hazards research community is committed to generating knowledge to help ensure that communities prosper and thrive.
The NEARI facilities, working with the civil engineering research community, have developed two resources as shown on the slide. The NEARI science plan, shown on the left, outlines research that can be conducted using the NEARI facilities to mitigate the impact of earthquakes and windstorms on infrastructure. The NEARI Impact Book, shown on the right, highlights recent research projects and innovations that have resulted from research using the NEARI facilities. The entire NEARI portfolio, as well as the NSF-supported research conducted at the NEARI facilities, and more broadly, all the research that NSF supports related to earthquakes and windstorms, contributes to NSF's role in two congressionally authorized federal interagency programs for mitigating the impacts of extreme hazards on the constructed environment, as well as fostering community resilience. These are the National Earthquake Hazards Reduction Program, or NEHRP, shown on the left, and the National Windstorm Impact Reduction Program, or NWIRP, or NWIRP, shown on the right. NEHRP is led by the National Institute of Standards and Technology, or NIST, and includes the Federal Emergency Management Agency, or FEMA, NSF, and the U.S. Geological Survey. And NWIRP on the right is led by NIST and includes FEMA, the National Oceanic and Atmospheric Administration, and NSF. Both NWIRP and NEHRP operate under strategic plans and work with academic researchers and practicing engineers to translate research into practice through design guidelines, standards, and code provisions. A current focus in NEHRP is designing structures for reoccupancy and functional recovery following an earthquake. We'd now like to highlight a few civil engineering related research and innovations supported by NSF and conducted at U.S. universities. The U.S. Eastern Coast and Gulf states annually experience devastating hurricanes such as Hurricane Sandy in 2012, Harvey in 2017, Florence in 2018, Laura in 2020, and Ida in 2021, which caused significant damage to many residential structures. This is of concern since the population in these U.S. coastal communities continues to increase, along with increasing construction along the coastlines. To better design and construct storm-resistant residential structures, a research team from the Oregon State University, University of Hawaii, and University of California at Berkeley tested a pair of 1/6 scale model structures subjected to simulated storm conditions in the NARI directional wave basin at Oregon State University. You may remember seeing the picture on the slide shown here, as these tests were also included in the video that I had just shown about NARI. In these tests, one model was elevated with the living areas above ground, and the other was on grade at ground level. As predicted, the on grade model did not withstand water levels as high as the raised one, and both structures sustained damage that was consistent with what was observed in Hurricane Sandy in 2012 and Hurricane Ike in 2008. These models were found to perform like actual wood frame homes during these hurricanes, and showed that scaled model buildings can provide much needed design information for structures that are located in areas vulnerable to storm surge. Artificial intelligence, or AI, with increased computing power, can help create safer, more sustainable and resilient structures and other infrastructure. Researchers at the NARI Computational Modeling and Simulation Center, or known as the SIM Center, have developed a suite of tools called building recognition using AI at large scale, or BRAILs, that can automatically identify building characteristics in a city and detect the risk to that city's structures during an earthquake or hurricane. This information is needed to simulate the response of buildings and model the extent of building damage across a community or region when subjected to an earthquake or hurricane. However, information on buildings in a city or across a region is not easy to document. However, using AI, neural network models can be trained to infer building information from images and other sources of data. To train BRAILs modules and run the simulations, the SIM Center researchers use the supercomputers at the Texas Advanced Computing Center at the University of Texas at Austin. BRAILs includes modules to predict a larger spectrum of building characteristics such as occupancy, class, roof type, foundation, elevation, year built, number of floors, and soft story features. The SIM Center has conducted simulations for several regions in the U.S. subjected to earthquakes and hurricanes that can inform decision makers about the extent of damage that can occur and where mitigation actions are needed. To reduce structural damage to bridges during an earthquake, researchers from Texas A&M University and the University of Colorado at Boulder have developed a new design called the Hybrid Sliding Rocking, or Hsr Bridge. Instead of a monolithic design for the bridge columns, these new bridges are made of columns containing limb-inspired joints and segments. During an earthquake, the joints allow some of the energy from the ground motion to spread, while the segments move slightly, sliding over one another rather than bending or cracking. Columns built with the Hsr design sustain less damage overall compared with bridges built with conventional designs, and the damage could be repaired relatively quickly with grout and carbon fibers. Research capacity in the U.S., as well as that in other countries, greatly benefits from collaborations with researchers around the world. One measure of international collaborations is the number of collaborative publications. Authors from South Korea have notably high collaboration rates with U.S. authors, among the highest of collaboration rates among countries with the U.S. NSF encourages international collaborations on NSF-supported research and education projects. Typically, each country supports its own researchers on collaborative projects. NSF supports international collaborations through its core research programs, research centers, and research infrastructure programs, research coordination networks, and through special solicitations such as accelerating research through international network-to-network collaborations, international research experience for students, and partnerships for international research and education. For more information about NSF, please visit the NSF website at nsf.gov. On this slide shows the NSF headquarters that's located in Alexandria, Virginia. And in conclusion, I would like to say that it has been my honor to have the opportunity to provide you with an overview of the National Science Foundation, its programs and facilities that it supports. NSF encourages international participation in the research and education projects that it supports, and we would welcome collaboration with researchers and educators from South Korea. Thank you.